What we're going to go over today is not in your textbook. So you want to be sure that you understand what I'm saying. If you need to pause it a few times, take some notes in order to get this down, make sure you do that. Because like I said, this is not in your book. You learned about solubility in Module 5, and we saw there that solubilities are often expressed in grams per milliliter or grams per liter. And so far, everything that we've done in this chapter is we've expressed things in moles. I want to make sure that you can take that and convert it to grams per liter. So this is not a difficult thing, but because it does go a step further than he does, I want to make sure that you understand how to do it. So I have a sample problem up here on the board. The KSP for calcium fluoride is 3.9 times 10 to the minus 11th. What is the solubility of calcium fluoride in water in grams per liter? Okay, so we're going to express it in grams per liter as opposed to moles per liter. So I'm going to start out working this problem the same way that I started working the other problems. First thing I'm going to do is I'm going to write an equation for the dissolving of this. So calcium fluoride is going to dissolve to give me calcium ions and fluoride ions. Okay, notice that I've got 2 fluoride ions for every calcium ion. Then when I write the KSP expression, my KSP is 3.9 times 10 to the minus 11th, and that's equal to the concentration of the calcium ions times the concentration of the fluoride ions squared. All right. I'm going to start out doing the same thing that I did before. I know that for every calcium ion that I have in solution, I'm going to have 2 fluoride ions in solution. So to plug that in here, what that's going to give me, I'm going to have an X here. The concentration of fluoride ions is twice the concentration of calcium ions. So that's going to be 2X, and then that's going to be squared. So this is going to be 3.9 times 10 to the minus 11th equals, when I work this out, that gives me 2X. The whole quantity squared is going to be 4X squared times X, which is going to give me 4X cubed. Okay, so you're going to divide both sides by 4. You're going to take the cube rooted out. You're probably really good at that by now, using your calculator to do that. So that's going to give me 2.1 times 10 to the minus 4th molarity for X. And notice that that is going to be the same as my calcium ion concentration, because this has a coefficient of 1 and this has a coefficient of 1. So therefore, X is going to be the solution to this one. All right, so they have the same coefficients. Now the question asked me what the solubility of calcium fluoride was in water in grams per liter. All right, now there is no concentration for calcium fluoride, but I do know the concentration for calcium. So what am I going to do with that? Well, I'm going to take 2.1 times 10 to the minus 4th moles per liter. And moles per liter of what? Well, that's of my calcium ions, okay? But what I'm asked for is the solubility of the calcium fluoride. Well, from the balanced equation, I know that for every 1 mole of calcium ions, I have 1 mole of calcium fluoride that dissolved, okay? That just comes from this balanced equation up here. Now, it's pretty simple because I've got this canceled out. Now all I have to do is convert from moles to grams. And you've been doing that for ages already. So in 1 mole of calcium fluoride, you're going to use your periodic table and you're going to find out how many grams there are in a mole. So that's 78.1, that's supposed to be an 8, 78.1 grams of calcium fluoride per mole. So now my moles are going to cancel out. And when I multiply that out, that's going to give me 1.6 times 10 to the minus 2 grams of calcium fluoride per liter of solution. Okay, so that wasn't difficult. Basically, I did the same thing as I did before. I just had to add this extra little conversion piece in here. And then I had to use the molar mass. And then I've got my concentration in place of moles per liter, which is what I've been calculating. I now have it in grams per liter. So I gave you several problems so you can practice working on that and get that piece of information under your belt.